The data that can be collected can either be a constant or a variable. Let's say there are five people A, B, C, D, and E. The number of eyes in each individual, the number of eyes in A is going to be the same as in B, is going to be the same as in C, is going to be the same as in D, is going to be the same as in E. That is equals to 2. So each of them have two eyes. That is, the value as per the individual does not change. And this kind of data is what we call a constant. However, if you compare the weights of these individuals, you'll find that there is most probably some kind of variation among them. That is, the weight of A might be 60 kg, B might be 65 kg, C might be 55 kg, D might be 70 kg, and E might be 120 kg. So there is a variation in the value, or the value changes. So the basic difference is that constant is that type of data for which the value does not change, while variable is that kind of data for which the value changes. And under statistics, you need to study about the various types of variables. Let's look at the various classifications of variables. First, we have qualitative variable versus quantitative variable. Qualitative variable, as the name suggests, includes quality, while quantitative variable includes quantity. Qualitative variable, number one, cannot be measured. Number two, cannot be compared. But quantitative variable, number one, can be measured and it can be compared. To understand that, let me give you an example. So let's take a quality for example. ABO, system of blood grouping. Under ABO system of blood grouping, you have four blood groups: A, B, AB, and O. Now, is this actually a qualitative variable? To answer that, you have to provide two questions. Number one, can it be measured? Can you measure the amount of blood group A present in a person? Can you say how much blood group B is present in a person? Can you say how much AB blood group is present on a scale for in a person? The answer is no. So it cannot be measured. Number two, can it be compared? Let's say there are two people, Ram and Syam. Ram also has blood group A and Syam also has blood group A. At this point, can you say that the blood group A of Ram is more than blood group A of Syam? And the answer is no. Since you cannot measure and you cannot compare this particular variable, it is a qualitative variable. On the other hand, let's take weight for example. You have weight of Ram which is equals to 60 kg, and you also have weight of Syam which is equals to 120 kg. So the first question, can it be measured? Yes, you are able to measure the weight of Ram and Syam. Number two, can it be compared? Yes, you can compare the weight of these two persons. You can say that the weight of Syam is double the weight of Ram. So weight is a quantitative variable. So the basic difference, qualitative variable, it cannot be measured and cannot be compared. Quantitative variable, it can be measured, can be compared. Other examples, you have pain. You cannot measure pain on a scale. Let's say Ram and Syam, both of them are pricked with a needle. Syam is more sensitive towards pain, so Syam shows more reaction. At that condition, you may say that Syam is feeling more pain than Ram, but in reality, both of them have been pricked with the same needle. So you can't really compare the pain of two different people. Another is RH. RH positive, RH negative. You cannot say how much RH positive a person has or how much RH negative a person has. You cannot say that a person has more RH positive than another person. Similarly, diabetes. You cannot measure diabetes. You cannot say that a person has more diabetes than another person or how much diabetes a person has on a scale. Similarly, anemia. The same logic applies here as well. Then, type of anemia. Then, sex of newborn. You cannot say that a newborn baby boy is more of a boy than another newborn baby boy. Or you cannot compare or you cannot measure how much a boy a newborn is. Since these variables they cannot be measured and compared, they are qualitative variable. In case of quantitative variable, you have height. Height of Ram can be X and height of Sam might be Y and height of Sam might be double the height of Ram. So you can measure and compare their heights. Body mass index, cholesterol level, cholesterol level. See, you cannot measure and compare diabetes, but you can measure and compare blood sugar level. You can say that the blood sugar level of Ram is 100 milligram per deciliter, and you can say that the blood sugar level of Sam is more or double the blood sugar level of Ram. Similarly, you cannot measure or compare anemia. You cannot answer the question how much anemia is present or does Ram has more anemia than Sam. But you can compare and measure hemoglobin level. So you can say that Ram has this much hemoglobin level and Sam has twice the hemoglobin level than Ram. Similarly, blood pressure is temperature, mid arm circumference, which is the circumference of the arm taken at the midpoint, pulse rate. All these variables can be measured and compared. So this was the first classification. Second, we have dichotomous variable versus polychotomous variable. In dichotomous, you have di. In poly, you have poly. Di means two, poly means many. So dichotomous variable is such a variable which has only two possible values, while polychotomous variable has more than two possible values. For example, RH blood grouping. It's either positive or negative. Similarly, HIV. You are either HIV positive or HIV negative. Similarly, diabetes. You either have diabetes or you don't have diabetes. Similarly, your weight above 70 kg. You are either above 70 kg, yes, or below 70 kg, no. Anemia. You either have anemia, so you are anemic, or you don't have anemia, so you are not anemic. So all these variables, they only have two possible answers. That's why they are dichotomous variable. In case of polychotomous variable, you have more than two possible answers. Like in case of weight, 60 kg, 70 kg, 80 kg, 90 kg, many. Height, 2 feet, 3 feet, 5 feet, 6 feet. Hemoglobin level, it can be anything. Sugar level, it can be anything. Cholesterol level, it can be anything. Blood pressure, it can be 70 by 120, it can be 100 by 120, 60 by 130. Your body mass index, body temperature, age, ABO system of blood grouping. You can have more than two possible values, A, B, AB, or O. Type of anemia, there are more than two types of anemia. and pulse rate. All these variables, they have more than two possible values, so they are polyquatomous variables. Okay, now you have the final classification of variables, and that is continuous versus discrete variable. Continuous variable has many possible values, while discrete variable has few possible values. But that's not the defining characteristic. The defining characteristic is that continuous variable has in between values as well, but discrete variable does not have any in between values. For example, for example, let's take weight for example. Let's say a person has weight 60 kg and another person has weight 61 kg. So is weight a continuous variable? For that, the first question, can it have many possible values? Yes, it can have many possible values. 60 kg, 61 kg, 63 kg, 70 kg, 70.5 kg, and many more. Number two, does it have in between values? See, between 60 kg and 61 kg, you can have 60.5 kg, 60.51 kg, 60.512 kg. So in between values are possible. That's why it is a continuous variable. For discrete, let's take RH for example. So does it have many possible values? Answer is no. It only has few possible values, and that is also only two. You are either RH positive or RH negative. Are there in between values? Are there any values in between RS positive and RS negative? No, you don't have any in between values. Like you can't be little bit RS positive and little bit RS negative. That's not possible. Either you are RS positive or RS negative. If you find all these information confusing, let me tell you a simpler trick to find out whether the variable is continuous or discrete. If the variable gives a decimal value like 60.51, it is continuous. But if it does not give any decimal value, it is discrete variable. Now let's look at other examples. Height. You can have decimal point of height. Hemoglobin level, sugar level, cholesterol level. See, let's say sugar level is 100 milligram per deciliter for one person and 120 milligram per deciliter for another person. Sugar level can have many possible values, number one, and number two, there can be in between values as well. You can have 101, 101.5, 101.25, and many more. Similarly, you have age. In age, let's say a person is 2 year or 12 years old, another person is 13 years old. In between them, you can have 12 years and 5 months. 12 years and 5 months. You can have 12 years and 4 months, and so on. You can even go till days. 12 years, 5 months, 6 days. Next, you have temperature. Similarly, you have body mass index. All these variables, they have number one, many possible values, and number two, in between values or values possible in decimal number. As for discrete, you have ABO. In ABO, you have either A, B, AB, and O, few possible values, and you cannot be in between A and B. You are either A or B. Similarly, anemia. In anemia, you either have anemia or you don't have anemia. You can't be in between having and not having anemia. Similarly, you have types of anemia. You either have one type of anemia or another type of anemia. You can't have the mixture of both the types. Obesity, you either have obesity or you don't have obesity. So that's your classification of variables. Let's do few practice questions so you'll have a proper concept. Okay, so there are three variables: weight, ABO blood grouping, and pulse rate. You need to classify these variables under the following types. First, weight. Can weight be measured? Yes. Can weight of two persons be compared? Yes. So it is a quantitative variable. Second, does weight have more than two possible values? Yes. So it is a polycotomous variable. Does weight have in between values? Between 60 and 61 kg, you can have 60.5 kg or value in decimal. So it is continuous variable. Second, ABO blood grouping. Can ABO blood grouping be measured? You cannot measure blood group A. You cannot compare blood group A of one person with blood group A of another person. So it is qualitative variable. Does it have more than two possible values? Yes, A, B, AB, and O. So it is polycotomous variable. And does it have in between values between blood group A and B? Is there something in between? No. So it is discrete variable. Finally, pulse rate. Can pulse rate be measured? Yes. So it is a quantitative variable. Does pulse rate have more than two possible values? Yes. So it is a polycotomous variable. And does pulse rate have in between values? Here's the confusion. If you measure your pulse rate per minute, just per minute, then usually you'll say 72 beats per minute, 73 beats per minute. You are not going to measure it in decimal, right? But this does not mean that pulse rate does not exist in decimal. Let me show you how. Let's say you have taken time duration of 2 minutes. Under 2 minutes, you measure the number of bits, and the number of bits comes out to be 143 bits. So pulse rate is equals to number of bits, which is 143, by time. So it comes out to be 71.5 bits per minute. So is the value in decimal as well? It is. So it is a continuous variable.